Hello, my name is Schmidt and today we will talk about artificial intelligence. So here a short overview of my talk. So first we will have a look on what is artificial intelligence, and because there has been so many interest into machine learning, we will clarify the relationship to machine learning. Then we will have a deeper look onto neural networks and deep learning. And finally, we will also look how we can implement our AI initiatives using open source software. And finally, there is a conclusion talking about what happens next in the area of artificial intelligence. Okay, so of course the question now, what is artificial intelligence? There are definitions. This one I like most from Strascheg, who writes a very important book on deep learning with Python. And he says it's an effort to automate intellectual tasks normally performed by humans. So we try to automate things, decisions, procedures that normally are accomplished by human beings and that are then transferred to computers. So the area of artificial intelligence is very wide. So there is artificial intelligence in a very broad sense. There we find also subjects such as robotics, symbolic AI, and so on. And then if we focus our interest, we see that there is machine learning with mechanisms like regression, recommender systems, and so on. And then there are neural networks. That is the area that got most attention in the last years because there were huge advances. For example, we now have machine translation that fits in many situations and achieves human performance. So let's first have a look on artificial intelligence, and here you can see there are many ups and downs. So the first ideas about something such as artificial intelligence started in the 1950s. There was a letter of Alan Turing where he envisioned something that would be called artificial intelligence today. And then the interest increased because in these years, the 1950s, 1960s, all the computers more and more got into traction. There was this famous Dartmouth workshop where people started to develop a research program for artificial intelligence. Then, of course, there were some disappointments. And that led to a decline in the interest of AI. Again, it climbed in the 1970s. Then there was a sharp decline after a Lighthill report that showed that artificial intelligence did not succeed in certain areas that were assumed as easy to reach targets, such as machine translation. And we had another climb in the 1980s and 90s. And so you see it's an up and down over the years, but in the last years we have a steep increase in interest to artificial intelligence. We can see that, for example, if we look at the attendance at large conferences, and here you can see this ancient peak of interest in the 1980s and early 1990s. Then we had, AI winter, so are these phases called, when, the interest into artificial intelligence declines. And in the last years, we have a very sharp increase. You can see it on the right side with this huge amount of participants in the large AI conferences. Let's have a look on some flavors of AI. First, and for a long time, the most popular type of AI is symbolic AI. It manifested in expert systems. So the idea was to extract the knowledge from experts in a formalized way. That means formulas or programming-like structures, and this was based on classical control systems, but it was connected with a very high effort. So everything has had to be created by humans, and so these computers could only do what the humans can do and what they are able to express. And this symbolic AI was a dominant paradigm from the 1950s to the late 1980s. But there was skepticism about this approach. So there is a philosopher, Polanyi, who wrote it down in this paradox: we know more than we can tell. And that was an experience many researchers in the area of artificial intelligence had. They interviewed experts, and they found often they use their rational mechanisms only to explain why they had decided in a certain way, but their decision was made already before. There were these critical voices, and also Moravec's paradox joins Polanyi. So he says, it is comparatively easy to make computers exhibit adult-level performance on intelligence tests or playing checkers, and difficult or impossible to give them the skill of a one-year-old when it comes to perception and mobility. So the observation was that these symbolic AI systems of the 1960s, 1970s were able to solve mathematical equations, to solve quizzes and so on, but it was difficult for them to differentiate two different peoples. Let's start now to speak a little bit about machine learning. So machine learning was the first approach to break with this classical engineering approach that is embedded into symbolic AI. Because here at the top you can see it, it takes data and the answers connected. So the machine learning learns from true or false examples, and it derives the rules automatically. And that's completely different to the classical programming or the symbolic AI that works as described below. So we have rules that are extracted or developed with the experts, and then we take the data and we get the answers. So there's a huge difference, and that made many people uncomfortable with this machine learning, because often it is not really possible to explain why certain rules are applied. We only can say that it is right from the perspective of data, that these rules were found in the data, but there is no explanation why. To explain a little bit the working of machine learning, here's a small example. So the interviewer asks, what's your biggest strength? So me, I'm an expert in machine learning. So the interviewer asks you, what's 9 plus 10? So I make my first guess, it's 3. Interviewer, no, not even close, it's 19. Me, it's 16. Interviewer, wrong, it's still 19. Me, it's 18. Interviewer, no, it's 19. Me, it's 19. You are hired. Yes, that's the way machine learning is working. So it's a trial and error process, and that slowly nears to the right solution. So the system does not learn rules from a symbolic representation, but it detects the rules from the data. Okay, so what is embedded in this machine learning? So we have some raw data. You see, it's perhaps difficult to find nice limitation between the two groups. So we can start here by changing the coordinates, and you see it's a little bit squeezed, but we can slowly see solution. And finally, if we normalize everything, we can see that we have a clear separation between the red and the blue ones. So, and in this manner work many machine learning approaches, for example, regression, where we estimate or predict the numerical value of some variable. Here, for example, we want to predict how many units of a certain product are sold at a certain temperature. Think, for example, of you're selling ice cream and you want to predict how many units are sold on a certain day with a certain temperature. So another important type of machine learning approaches is clustering. So here we don't know right solutions, but it's about finding associations, to finding groups of products or individuals that share certain properties, and therefore we create different clusterings. The interesting thing is there often is no right solution, because we don't know even if it's delivered to us. Instead, we have to test it in practice, but the clustering helps us to find different associations of individuals, for example, customers that have the same requirements.